Formic acid has a Ka of 1.8 times 10 to the negative fourth. What is the pH of a 25 milliliter sample of 0.205 molar formic acid after 10 milliliters of 0.1 NaOH has been added? Alright, so we're actually titrating, or doing that titration type setup of a weak acid and a strong base. So our first step is to figure out which one is in excess, the OH or the HA. And we're going to do this in terms of moles. So our initial moles of HA is going to be that 25 times the 0.205, or more specifically we want to do 0.025. I don't see my mouse. Figures. There we go. So 0.025 times the 0.205 for the molarity tells me that my initial amount of moles of HA is 0.005125. And we're going to do the same thing with our NaOH and get that that's 0.001 moles. Alright, our smallest of the two goes to 0. And since I have HA remaining, I will need to know how much A minus is produced, which is positive 0.001. So the amounts we're working with, moles-wise, of our HA and A minus are what we figure out. Alright, since we have HA and A minus remaining, we are in a situation with a buffer, and our equation to plug in and solve for a buffer just has that relationship with the A minus over the HA times our H3O. And we're going to use that to get our H3O. So what I mean by that, we'll have this at 1.8 times 10 to the negative fourth. We can turn these into concentration, but since it's just that ratio and they're all in the same container, we can do this with the A minus over the HA from just the amount of moles. And we're just going to solve for our H3O concentration and then turn that into a pH. So I have 1.8 times 10 to the negative fourth times 0.004125 divided by 0.001 gives me this, which would be my H3O concentration, and so I will just take the log of that value and we get a pH of 3.13.